Section 4.3, example 5 on page 251, we have recall that if you get a false statement as you solve a system, then the system has no solution. If you get an identity, then the system has infinitely many solutions. Example 5 says how many solutions does the system have? Equation 1 is 2x plus 6y equals 18, and equation 2 is x plus 3y equals 9. I have the same reminder up at the top. Let's start by taking a look at the coefficients of our x variables. In equation 1, we have a coefficient of 2. Equation 2 has a coefficient of 1. We can make our coefficient of 1 match the coefficient of 2 pretty easily. But let's double check to make sure that the coefficients of y don't already match. We have 6 and 3. Those don't match, so we can focus on either the x or y. Both can be manipulated to match. If we choose to make our x values match, we can multiply the second equation by negative 2 to get negative 2 times x is negative 2x, negative 2 times 3y is negative 6y, and negative 2 times 9 is negative 18. Now moving on to step 2, we can add the two equations straight down. So using our original equation 1, we have 2x plus 6y equals 18, and we're going to add negative 2x minus 6y equals negative 18 from our new equation 2. Adding straight down, we get 2x minus 2x is a 0 pair. 6y minus 6y is also a 0 pair, so we have nothing left on the left-hand side. You can't leave it blank though. Nothing left means we have 0. And then on the right side, we have 18 minus 18, which is also a 0 pair. So again, we have to write 0. This leaves us with the equation 0 equals 0. This is what we call an identity. 0 does indeed equal 0. Therefore, example 5 has infinitely many solutions. The work for this problem is written out on the next slide. And then we have a flowchart on page 251. The flowchart below can help you decide which steps to take when solving a system of equations using elimination. So first you want to think, can I eliminate a variable by adding or subtracting the given equations? Yes? Then you can do that. If not, think, can I multiply one of the equations by a number and then add or subtract the equations? If so, you'll do that. If not, multiply both equations by different numbers and then add or subtract the equations. Now I would like you to try number 10 on page 251. Tell whether the system has one solution, infinitely many solutions, or no solution. For number 10, we have 4x minus 7y equals 15 and negative 8x plus 14y equals negative 30.